Hello everyone. It's great to see you guys join early. Stay tuned, we will be starting shortly. Hello everyone. It's great to see you guys. Stay tuned. We will be starting shortly. Hello Sandeep.
Hello, hi.
Hi, I'm Shivam. I will be the today's moderator.
Thanks, Shivam. It's wonderful to meet with you.
Same here.
Shivam, let me know if you can see me.
Yeah, you are visible.
Okay, I'm going to share my screen as well. So let me know if once you.
Yeah,
Okay, good. Thanks, Shivam.
we will be starting in 4 minutes.
Sorry.
We will be starting in 4 minutes.
Okay, that's fine. I'll go on mute then.
Hello everyone. Welcome to another session of DataHour series. We will start in 4 minutes. Till then, let's get to know each other. We have put up a poll which contained 2 questions about your location and experience level. Kindly answer the question in the poll. Hello and welcome everyone to another session in the Data Art series. We are thrilled to be here with you this afternoon and have a session full pack of learning. I'm Shivam, part of data science team at Analytics Vidhya, and I will be the moderator for today's session. For those who have joined us for the first time, a brief introduction to the Data Art sessions. The Data Art is a series of webinars conducted by Analytics Vidhya and led by top industry expert. It is a fun way to understand the concepts of data science and the leading players in data science tech domain. And as the name suggests, it's 1 hour dedicated to data. We hopeful that these sessions are going to be great source of enrichment and value adding to our community members. Now on to our session today, which is data operation on Azure. Azure, formerly known as Windows Azure, is Microsoft public cloud computing platform. It provides a range of cloud services, including compute, analytics, storage, and networking. Azure provides robust services for analyzing big data. In this data hour session, we will know how to perform data operation on Azure. I hope you guys are excited to attend this data hour with us. Before we kick things off and I hand it over to our speaker, a quick recap of your housekeeping items. We are recording this session and will provide you the recordings available in few days on our YouTube channel. Please use Q&A section for asking any question you might have during session, and we will do our best to answer them as the data are progress towards the end. Also, we will share a poll about the feedback towards the end of the session, which I request you to kindly fill up. Now, on to our speaker. In this session of DataHour, we have Sandeep Bhalekar with us. Sandeep is founder of Bhalekar Consulting and has close to 20-year experience and worked as DataOps head at Department of Health, Vice President of Internal Audits, Data Science Projects at Bank of America, Associate Director for a Reg Reporting Projects at NBA. Sandeep has created many high-performing teams and data architecture through his career and is currently helping large-scale industries to scale up their data transformation capabilities. Over to you, Sandeep. The virtual stage is all yours.
Thanks, Shivam, and everyone else. Please welcome on this session. As you are, and as you know, that this particular session we are going to talk about data operations on Microsoft Azure. Now, in general, this topic is quite dear to my heart, not only because data operations is end-to-end journey of the data, but also it's combination of data and cloud. So we will see how exactly that operations can be done on Microsoft Azure. Now, something about myself. As Shivam introduced, I have close to 20 years of experience. I led multiple teams across the globe. I was in Singapore. Currently, I'm in Australia. So I have worked in various companies, banks, in various geographical locations. Especially, I come from banking background, and currently I have been consulting to one of the major Australian government for COVID reporting. So my contributions to banking and COVID, obviously, that led from data operations perspective. So I'm really excited to share the knowledge which I and the learnings I had throughout this tenure. So getting started, the agenda for today is basically we will look about or know about what is data operations. We will identify key functions in data operations, sample data ops team, how the data operations teams look like. Analytical maturity curve, we'll see exactly how we see that organization is mature. Also, we will look at Azure solutions path, which path you need to take to mature or create the solutions on Azure. And last but not least, we'll see some sample data architecture. Now, thanks for the poll. And obviously, the poll represented that most of our attendees today is 0 to 3 years experience. So I'm not going to make it very technical, but I will give you some ideas where you can transform your career or we can project your careers towards, and where exactly the industry requires a lot of these skill sets. So that can benefit you. Now, fun fact, about 88% of the data goes unanalyzed, right? So this is the fact for today. Obviously, only 15% of the data, big data projects, make it into the production. So that summarizes like how much data we have available versus how much data we are actually using. So that is not only because of the skill sets gap, but also because industry is still growing and maturing. So that is a good thing for the young crowd in this presentation or audience, that this particular opportunity you obviously can make use of that. Now, talking about what is data operations, right? So data operations, as name suggests, is data plus operations, right? So ensure data value is delivered to the business as soon as possible. So there is many of the times it is confusion between data operations versus DevOps, right? Data ops versus DevOps. So we'll see what exactly is the difference. But from data ops, we always bring data value to the businesses. So during that process, we also do automation and process to improve quality and life cycle or cycle time for the data analytics. And you can see this infinity diagram. You can see the similar kind of infinity diagram for DevOps as well. So it starts with planning, creating solution, orchestrating, and then continuous integrations and deploying to the production, then operate, monitor, and optimize the solution. So this infinity cycle indicates that it is continuous delivery, continuous integration, kind of a life cycle. Now, the most confusion occurs in data operations versus DevOps. So, in a layman's world or word, DevOps is delivery of value of DevOps is software engineering, right? So, DevOps is mostly used for the software engineering, where softwares are built or code is deployed in a certain particular way. The quality assurance of DevOps is code reviews, continuous testing, and monitoring. So, if you can see the overlaps here, so software development, quality assurance, technology operations. So all these teams come together, and the integrated value is derived from the DevOps. Now, when we say data ops, it is slightly different, right? So it is related to data focus, right? So the delivery value of data ops is data engineering, analytics, and business intelligence, and data science. So you can see that the quality assurance of the data ops is data governance and process control. So you can see a small tiny portion here which indicates a data ops. So it has overlap between data quality, data engineering, data ingestion, data security. So all these functions come together and form a data operations. Very interesting field. Obviously, we'll look and go deep dive into this in the session today. But to understand what is the identify what is the key functions in data operations. So first and foremost, most important thing is tech stack, right? So is it a public, hybrid, or private cloud infrastructure? What data warehouses or VMs we are using? Now, for today's session particularly, we are going to look at Azure, which is a cloud infrastructure, right? So we will look at that, but tech stack is very important as a first step. Second step is platform engineering, right? So is it like when we say platform, if it is private infrastructure, the infrastructure maintenance, if it is cloud, obviously cloud management, virtual machine management, and other computes and database management, all these functions fall into platform engineering. And most important for data ops is data engineering, which is ETL, ELT tools. Like in Azure, we have Azure Data Factory. We'll discuss about that. And then programming language like your SQL, Python, R, or others, Scala or PySpark as well. So this data engineering is a vital part of data ops. And last but not least, whatever data operations we are doing, whatever transformations we are doing, we are ultimately doing it to push the code in production and make use of whatever solution we are building on production itself. So the release management comes in the picture. So in data ops, we still follow the DevOps release management processes. So there is a bit overlap between DevOps and data ops as well. Now, talking about the sample team, and obviously this is the data ops sample team where you have a data ops manager who is executive, and there is one data architecture who designs and architect the data operations. And then there is data engineer. The role of data engineer is to basically create the data architecture, data model, doing the data modeling, doing the responsibilities include data lakes, data warehouse, and database programmings, and obviously doing the transformation of the data. So data engineering is responsible to bring the data from the source to the data warehouse. Then we have data analyst. Now, data analyst is responsible for obviously understanding the data, doing the evaluations on the data, analyzing the data, and putting the business value from the data. Now, as we all know, right, there is a saying that 80% of data scientists time goes into data engineering, right? So when I started the career, there was no term called as data engineering. Right? So we have dedicated person now who does the data engineering for us. And that is the reason I think the data engineers are getting really populated, and they are really high demand, because I think the amount of work and the kind of data cleaning and preparation data engineers do, they are not only beneficial for data analysts, but also our data scientists, because they get the readily available data which they can use and do the further feature engineering if it is required. But the most of the transformation is done from data engineering point of view. Then we have the cloud engineers. Obviously, when we say platform support or platform engineer, there is a cloud engineer. So they can create the security required for this particular data operations. They can also create ARM template and other templates which can be used, and work through the services required for the data operations. So that services could be, sending an email notifications using logic apps or any other such applications on Azure or any other cloud that for that matter. But cloud engineer plays a vital role in DataOps team in today's infrastructure, considering it's everything is on cloud. Then obviously data quality analyst plays a vital role for analyzing the data and checking the quality of the data. And last but not least, when we go to prediction level, data scientist plays vital role for creating the machine learning models and even computer vision or any other such models, and training a model and putting that models into production. And all these people, they work with each other, collaborate and perform tasks for one particular goal, which is making this data operations working for the organization. Now, talking about analytical mature curve, right? So obviously we are talking about descriptive statistics, and then obviously it is diagnostic, predictive, and then finally it is prospective. So most of the task or organizations, they mature from descriptive. So they want to analyze whatever is the historical data they have, and they do the basic reporting. And from there, the basic reporting is needed to understand what exactly happened. Then from there, they can analyze why it happened, right? So self-service reporting and other things can be categorized into why did it happen. And then obviously we go to the predictions and what may happen in future based on the data what we have. So now obviously we are talking about predictive analytics. Also, the exploratory analytics is part of, it can be help organization to understand some of the predictions. But most importantly, most of the organizations, they want to get a lot of value from the data is in terms of real-time analytics. That means from the IoT devices, when we look at the data, we want to analyze the data and give the value immediately, right? So if your Apple Watch is monitoring your heartbeats or rate, we want to get that data and analyze it and obviously provide us results on a real-time basis. So the real-time analytics is very important aspect of this maturity curve. And last but not least, the real-time predictive modeling and mining is the ultimate goal of most of the organizations, where they can do the event-based and event-based data discoveries. So that is about the maturity curve. Now we will go ahead and talk about little bit about Azure. As you can see that various SQL Server and Azure in big data solutions, they can look like this: the control versus ease of use, right? So this side you can see the control is on the left side, and on the right side you can see the ease of use. So if you want more control, you can choose Azure Marketplace SQL Server Studio, and you can have, this is infrastructure as a service clusters. It has reduced, obviously it has a lot of administrative values there. And obviously once you go this side, like Azure HD Insights, SQL Server Analytics, Integration Services, these kind of services, little bit easier. Now Azure Databricks is very popular in industry nowadays. So if you want to learn about this really good, it can add a lot of good value to your profiles as well. So Azure Databricks, SQL Server Analytics, this is definitely easy to use. Databricks provides notebooks, where in that notebooks you can use Spark, you can use SQL, Python, or any other. And Databricks comes with its own compute. So that means obviously you pay for what you use for, right? So good thing about is, because this is not one programming language dependent. That means in a single notebook you can use SQL, you can use Python. And this is really important when we are talking about data operations teams, where you have a data analyst and data scientist working together. One person may be really proficient in SQL, other person may be proficient in Python or R, and they can obviously come together, collaborate, and work on the same notebook at the same time. And last but not the least is Azure and SQL Server Data Lake Analytics. This is definitely data engineering in a job as service model, or this can be, you can also call it as big data as a service model. So this is really easy to use. And so depending upon which organization you are using, working for, and what sort of requirements they have. You can choose any of the model, whether you need more administration, more control, or you want easy to use kind of infrastructure. Based on that, you can choose any of these buckets. But obviously, there is a Azure and SQL Server Studio data lake. This is like you can use these big data storages depending upon availability there. Now, when we talk about data architectures, obviously the data is coming from various schemes like ERP, your CRMs, images, even social media, machine logs, and text, audio, and video files. So all these different types of data, obviously, you need a place where you can store the data and do the real-time processing there. So if you look at this particular architecture diagram, you can see the data platforms. You can use any of these data platforms, obviously, for fast loading, filtering, and processing, exploratory analysis, online archival, and you ingest the data into data warehouse, like for business analytics, high concurrency, and strict SLAs, operational intelligence. And then integrated discovery platforms. You can use this same data architecture for data discovery, graphs, time series analysis, integrated analytics. So the same data architecture can be used for marketing applications, business intelligence, data mining, mathematics, and statistical analysis, using for NLPs. So yeah, that same architecture can be used for multiple use cases. Now, another view of from various data sources, you can see it's online, OLTP, or mobile, or unstructured data like graphs, social media. IoT devices are emitting data every second nowadays, obviously. So IoT devices, media files. From these sources, data is pulled into data management platforms. It could be on-premise. You can use data warehousing, or you can even use big data processing like Apache Hadoop. And it can work in combination of on-premise or versus cloud, kind of a combination or collaboration. But if you're using cloud, Azure SQL databases, Azure Cosmos DB, or Azure Document DB, Azure SQL data warehouse, SD Inside, or Azure Data Lake can be used for storing data as well. And finally, what value you can bring from this data management is your PBI dashboards, SQL Server reporting. If you want to do some further advanced analytics and AI, you can use SQL Server Analytics Service built in, or Azure Machine Learning, Azure Stream Analytics. So these are some of the services provided by Azure itself. And in terms of Azure security, obviously, it's there's more certifications than any other cloud provider. Azure is very industry standard and leading platform when we talk about cloud. And lastly, the flexibility. You can code from any of the, you can code .NET, Java, Azure, its own Node.js, or any other Python, or any other coding languages on Azure. Now, when you are choosing Azure solutions, right, you can either choose infrastructure as a service or a platform as a service. So if you choose infrastructure as a service, you can obviously look at SQL Server in Azure virtual machines, right? So you can get a virtual machine and use SQL Server on that virtual machine, and you have complete control and flexibility of how exactly you want to use that virtual machine and generate value for your organization. If you want to use Azure as a platform as a service, or PaaS, then you can use Azure SQL databases. And it's pretty straightforward, because when the data is in database, it's very quite simplified for the administration perspective. And some of the use cases are obviously cloud designed business apps, websites, and mobile apps extend on-prem, all-premise. So these are some of the solution pathways. You can choose any of the pathways. Now we'll see how exactly, or what are the common data architectures on Azure. So the first data architecture, you can see that big data and data warehouse, is a simple or most common kind of architecture. You can put any of the buckets here. So first step is obviously ingesting the data. So no matter which kind of category of data you are pulling in, whether it is a graph related data, images, social media, or IoT devices, or any other cloud You are sourcing the data from various these sources, and you ingest that data into data warehouse or big data using Azure Data Factory. So this is obviously data engineering comes into place for ingestion, and then SQL Server integration services. Then after ingesting the data, you need to understand or decide where exactly you're going to store the data. You can store the data in blob storage or S3 buckets in Amazon. Blob storage is obviously is a simple storage, or you can choose Azure data lake store, right? So if you have a lot of data, and Azure Data Lake provides you opportunity to store endless amount of data, right? So it's not infinite, but it is close to infinite. So you can choose Azure Data Lake if you have a lot of unstructured kind of a data. You can even store the data in SQL servers or data warehouses where you have structured data and data is coming from very structured values. You can choose to store in a relational database kind of a store. After storing the data, obviously the next step is preparing and training the data. So if you are using any analytics engines like Databricks, HD Insight, Data Lake Analytics, SQL Server, R and Python integration services, you can obviously create the machine learning models or any other models, and prepare the data accordingly, train the model, and obviously then next step is model and serve. So you can use Azure data warehouses for storing that outputs, and Azure analysis services, SQL Server, and all this then fed to the reporting layer. So when we say reporting layer, it could be a real-time analytics, it could be advanced analytics, it could be business intelligence or reporting using Power BI or Tableau or any other reporting platform for that matter. So this is a very generic kind of a flow of how the data flows from front to back. So it shows the complete picture of data operation from a source system to the reporting layer, right? So there is heaps of things happen in between, and data engineers and other cloud engineers, they do wonder in those intermediate steps. So this is one of the data warehouse, modern data warehouse kind of a data architecture. So here basically we are importing logs, files, and media which are in unstructured. And you can also see that there are we are also getting some data from business custom apps which are structured. So this is a combination of structured and unstructured data. So in the ingestion layer, you can see that for the unstructured data, we are using Azure Data Factory, SQL Server integration services, or so ADF can pull the unstructured files, and these unstructured files can be stored into blob storage. If there are like structured data, we can use ADF and we can directly store the data into a data warehouse, because it's a quite straightforward structured data. We can put them in the staging tables, and we can use further processing like Azure analysis service or SQL Server analytics service. And finally, it goes into reporting layer, as we have discussed in the previous slide, analytics dashboard or Power BI dashboards. Now, if it is unstructured data and we want to store, obviously we stored it on blob storage, and we want to prepare and train it in terms of models, then obviously we are using Azure Databricks or SQL Server R or Python integration services to train these models. And from this, we obviously put that into Polybase and store that data into Azure SQL data warehouse. So this is kind of a modern data warehouse kind of a concept. Now, yeah. The next kind of architecture we have is advanced analytics kind of a architecture. So these are some of the architectures we have in industry, and we are just discussing. There is no right or wrong. We can choose any of the architecture, or you can create any architecture in the combination of multiple architectures we are discussing today. Now, for the advanced analytics architecture, you can see that there is unstructured and structured data we are ingesting into our shop. So first thing is ingesting. Obviously, we are using as ADF again, storing the data into blob storage. And in terms of preparing the data, you can see the little difference here. Like we are using Azure machine learning service, and also in combination of Azure Databricks. So in Databricks, we are using Spark ML, Spark R, and in combination of R and Python integration services. So all these preparation and training of the data models can be fed to our data warehouse using Polybase. And further to the data warehouse, we can use Azure analysis services to transform the data or do the model or data model there, which obviously can be fed into various analytical dashboards or further reporting. Now we'll also discuss the real-time analytics kind of a data architecture where we want to analyze the data in a real time. So in this example also, you can see there are combination of unstructured and structured data. And in terms of unstructured data, because this is I have given Apple Watch or any smartwatch example where you want to analyze the data and provide this results real time. So most of the IoT devices, obviously, they emit the data, and expectation is we use that data in a real time and provide some outputs using that data. So the unstructured sensors or IoT data, we can ingest them in our Azure shop using Azure IoT Hub. This is another wonderful service provided by Azure. Or you can use Azure SD Insight or Kafka for ingestions. And once the data is ingested, you can store that data either into blob storage or data lake store. And then that storage can be used for preparing the machine learning and other models using combination of Azure machine learning service as well as Azure Databricks using Spark ML and Spark R. And once the preparation and training of the models are done, then we can store the outputs or push them into either into reporting layer straight away, or using the Polybase, we can also decide to put the outputs into data warehouse and use the analysis services as a interim step before we push the data into Databricks, to the Power BI analytical dashboards. And for the structured data, the process is similar. From ADF, we either want to put the data into blob storage, or we can straight away put that into data warehouse, depending upon what do you want. So this is some of the real-time analytics kind of architecture where we are collecting the data, structured and unstructured data, and preparing the model and pushing the data in a real time to the reporting layer. Now, when we talk about real-time analysis, we can also talk about intelligent applications, right? So in intelligent applications, we are obviously going to talk about IoT devices, where we are going to use Azure IoT Hub and Azure SD Insight or Kafka. And the only change which this architecture has is we are using Azure Databricks and SD Insights. And from this planning and training, preparing and training of the models, we are simultaneously putting it into Cosmos DB or SQL databases for further processing and servicing. Versus in the prior model for the real-time analytics, we were pushing most of the data into Azure Analytics and operations and reporting layer. So these are some of the examples of the architectures on Azure using various Azure services. But most importantly, I wanted to show you how exactly the sample data engineering looks like on a data operations. Now, some of these services I can explain you, but yeah, if you want to choose a path where you want to become a data engineer or a cloud engineer on Azure, the expectation will be that you precisely know most of these services provided by Azure. So first is obviously we are this is the on-premise kind of a shop. From on-premise, we are pulling the data into our data operations or on Azure. So on-premise shop could be any Oracle or any other store for that matter, or any ERP software from where we are importing the data. So for that importation, there are multiple developers who are working on this on-premise. They can create these active directories. Now, active directories are used for securing or access management. And only people who are on this active directory can get access to some of these things. Now, Key Vault is another service provided by Azure where you can keep the secured information, passwords, and other things. But most importantly, if you choose to become a data engineer, you need to know how the data factory works. So data factory is ETL tool provided by Azure. And we have already discussed about Databricks, a data lake storage, and Synapse Analytics. So this is a dev. So the blue rectangle you see is a dev system. And from dev, once the developers create this code, that code is pushed into a QA or quality analysis or pre-prod kind of an environment where the code is further tested. And if the code is really doing as it has, obviously as planned, then code can be pushed into production. So you can have this kind of different environments, dev, test, pre-prod and prod, or dev, test, and prod, depending upon your budget and the available shop. But yeah, the dev code is tested here, and if everything is working well, it is pushed into a test environment where further testing is done. And finally, if everything is working well, it is pushed into production environment. Now, these environments, you can see that, controlled by Azure resource groups, so this is the dev resource group, QA resource group, and then prod resource group. And each of these environments, they have their own services attached to them. Now, in terms of this version controlling or release management, in Azure, we use DevOps pipelines and Git repos. So we're using the both combinations. We deploy in a real time, an automated way between various platforms. And finally, Azure also provides you DevOps, where you can use the wiki and other things, other services provided by Azure. So that was the basic things related to data operations. We have discussed about various architectures. We have also discussed about some services on Azure. We have also discussed about career paths which we can take and divert our profile either as a data engineer, data analyst, or data scientist, or cloud engineer, data architecture. So all these things we have discussed today. Now, before we conclude sessions, just wanted to take questions now.
Please use Q&A section for asking any question you might have during this session. Before we proceed to answer your question, I would like to request the attendees to please fill in the feedback code. So the first question is, DevOps and MLOps are the same?
Okay, so it's a very good question. DevOps or MLOps, they are different. So we have already discussed about what is DevOps versus DataOps, right? So the question is related to what is MLOps, like for machine learning models. When the models are created, there is certain operations happen for this, for specifically related to machine learning models itself, from business understanding, data preparation, data or model deployment, and so this entire circle, obviously, you require some operations to be done in terms of machine learning in itself. So MLOps is a part of DataOps, but MLOps is it sits on its own, and ML operations can be identified as a separate entity in terms of operations.
Please explain Databricks in brief.
Okay, so Databricks is nothing but a platform. And Databricks is it can be integrated into Azure, and Databricks provides its own compute and its own UI if that makes sense. So Databricks, you can imagine that you probably, most of you have 0 to 3 years experience, so probably you must be having idea about Jupyter notebooks. So Databricks provides something similar to Jupyter notebooks. They have Databricks notebooks, and those notebooks you can use various programming languages, but it is widely known in industry or widely used in industry for data engineering, because you can put Databricks cluster in the pipelines as an interim step. You are pulling the data from sources using Databricks. You can transform the data. You can use machine learning on the same notebook and transform the data, and in the same pipeline, the output can be pushed into the ingestion layer or reporting layer. So Databricks is a platform which provides you power to transform the data or do the transformation on the data and use various programming languages. And Databricks comes with its own compute, so it is quite cheap to use.
Why ELT is required if we have ETL?
Now, ELT and ETL is basically same thing, but obviously the sequencing is different. And both the things are required depending upon what you are trying to achieve. So some of the use cases, the transformation is needed before we ingest the data, so that the database is clean. So transformation is already done, and in your data warehouse, you have the transformed data. In some of the instances, we want to understand how the transformation is done, the journey itself we want to capture in our data warehouse. So then in that way, we load the data first and then transform the data in our shop or in our data warehouse. So that is the difference. Both the things are relevant and can be used vice versa.
Is Databricks a cloud data warehouse similar to Snowflake's?
Databricks is not a data warehouse, but it is a cloud platform which can be used in integration with cloud service providers. It can be used in integration with AWS. It can be used in integration with your Azure or GCP. But it is a platform on its own, and it comes with its own compute. So you pay to Databricks for what you use it for. That means you have created one notebook, and unless you run the notebook, there is no need to pay to Databricks. So it comes with its own benefits.
What is the alternative to Databricks in AWS?
Databricks can be used in AWS, as I said, but Databricks is, again, it's a ETL tool, and it can be used for machine learning as well. So it's just a comfort which tool you want to use. But Databricks, there are alternative solutions for Databricks, like AI Robot, Data IQ, or other such products. Yeah, but it can be used in AWS as well.
How can a data scientist upgrade to MLOps?
Okay, it's a very interesting question. Now, I want to answer it from both the perspective. Now, there are instances where obviously these operations people, they can be either from system administrative kind of a background, or they could be from a data analyst kind of a background. But yeah, if you have the understanding of the data, then obviously in my career, I have seen that the more successful people, they come from data scientist background, and or data analytics background, and then they become data operations leads or something similar. Even MLOps, for that matter, if you understand the data, that can give you a lot of value. Or if you're coming from IT security or cloud platform management, then you need to step up yourself and understand the data first, because ultimately we are delivering the data to the source, right? So we are delivering some data to the businesses, which they are going to use the data and obviously bring value from that data. If you don't have understanding of how the data is going to be used, then I think there are some hurdles in terms of success in terms of that role. So MLOps, again, data scientists can become work in MLOps. And the pathway is very straightforward. You just have to work on operations side rather than building the model or development, right? So you have to work on operations side. So you have seen this infinity diagram. So it's dev and ops. So from the development until the deployment is the dev team's responsibility. Once the code is productionized, once the code is put into production or stored into production, then the operation teams maintain that code. So if you are a data scientist, you can develop the data science models, or you can maintain the data science model. In a layman's world of you want to work in an operations side, you can obviously work and maintain the model. But the most important thing is you need to understand what exactly the data is doing.
I have knowledge of Python, SQL, machine learning, DL. What part of Azure I could learn for my career, and what role could I start my career with?
Okay, so I think you have most of the information needed to get started with Azure. Now, my recommendation for you is start with AZ 900, which is a basic certification Azure provides. And if you attend Azure training, this certification comes as a free, and you will get complimentary certification. And what that certification provides you is introduction to various Azure services. And from that, the next progressive training is, I think, DP 900, which is data analytics on or data platform on Azure, and which will provide you most of the services using data related to data on Azure. So that is the natural progression. These two certifications I would like to recommend you. And based on after that, these two certifications, either you want to, whatever pathway you want to choose on Azure, maybe you want to become a data engineer, you can choose that path. If you want to become a data analyst, you can choose Power BI certifications. If you want to become a data scientist, you can choose that path. But this to get started with Azure, I would highly recommend these two certifications. Both the certifications are free. You just have to register for these on Microsoft website. And once you complete the training, you can get you will definitely get that course from Microsoft where you can use that codes to book the exam for free.
Okay, so I guess we are over with the Q&A section. Thanks a lot, Mr. Sandeep, on behalf of Analytics Vidhya. I would like to thank you for the time and for delivering such a wonderful session. I'm sure our audience found it insightful and helpful. We can conduct more sessions with you in the future.
Yeah, definitely. I mean, feel free to connect with me on my LinkedIn or send me an email if you have any questions. I'm really happy to connect with you all, and excellent opportunity for me to speak at Analytics Vidhya, which is a very dear platform to my heart. So thanks a lot.
Thank you. I hope you guys have filled the feedback polls. If not, I request you to please fill the polls about the feedback, as it helps us to conduct more such sessions. The recording of the session will be available in a few days on our YouTube channel, and YouTube channel link is in the chat box. We will be back with another session in some hours, because we have another session in today's evening. So till then, bye-bye and keep learning, everyone.